Hello everybody, I am Kiran Kumar from Nature of Physics. Today topic is wave motion from this displacement of progressive wave equation. Please do like and subscribe our channel Nature of Physics. Along with the 4 numericals I am going to explain, that is PYQ question student. During the progressive wave, the particles of the medium performing simple harmonic motion about their mean position. Okay student, I am considering this is the x-axis and this is the y-axis. O is the origin. See student, this is the progressive wave traveling like this student. See there, at particular one position, okay, its vertical displacement is y related to y-axis and horizontal displacement is x, and the wave is moving with a velocity v student, clearly represented in the diagram. Okay, suppose a plain simple harmonic wave traveling from the origin. This is the plain simple harmonic wave traveling from the origin O along the positive x-axis. This is the positive x-axis, from left to right, clearly diagram represented. Okay, and the displacement y of a particle at O from its mean position at any time t is given by basic equation y is equal to a sin omega t. This is I wrote from the simple harmonic motion. Okay, and next one, the wave reach the particle to the p, which is a distance x along the x-axis at a time t. So time taken by the wave is t, is same as motion of the particle at x is equal 0 at the earlier time student. For this earlier time is written t minus x divided by v, and this value is replacing in the equation 1. Hence the displacement y of the particle p at a distance x at a time t. So instead of t I am writing there t minus x divided by v. This is written as equation number 2. Okay student, and then continuation different equations I am going to write. See, for first one, the basic equation I am considering already written here. So that is y, which is equal to a sin omega into t minus x divided by v student. Okay, so the basic equations, that is omega, which is equal to 2 pi mu student, and next k, which is equal to 2 pi divided by lambda. Okay, k is the propagation constant, omega is the angular velocity of the wave. The values we are replacing step by step, we will get the different derivations. First I am multiplying with omega, so that, see student, for this y, which is equal to a sin omega is multiplied omega t minus x divided by v into omega. Okay, so that velocity of the wave v, which is equal to omega divided by k, this is represent the wave velocity. From this equation, okay student, that is k, which is equal to omega divided by v. Rearranging the equation is replaced in the above equation. Instead of omega by v I am writing k student, so that equation y, which is equal to a sin omega t minus kx, this is I am writing as equation number 3 students. See there, continuation. Okay, 2 and 3. Okay, and also we can write this equation y, which is equal to a sin kx minus omega t. This equation proof I will give the links my video only from Nature of Physics. So both equations same only, I gave you proof. The video link I will provide in the description. Okay student, and different form of progressive wave equations I am going to write. See student, that is omega, which is equal to 2 pi mu, and k is equal to 2 pi by lambda. Both values are replacing in equation number 3. So that y, which is equal to a sin omega value is 2 pi mu minus, already t is there, minus, tell me student, k value is 2 pi by lambda into x student. In the next step, a sine 2 pi is common student, that is mu t minus x divided by lambda. Okay, y which is equal to a sine 2 pi. So frequency, I am writing here, frequency is inversely proportional to the time period of the wave student. Okay, so that small t divided by capital T, small t is at particular instant of time. Okay, capital T represent time period to complete one wave, minus x divided by lambda. And then continuation, next step, y which is equal to a sine 2 pi, and denominator lambda is common student, that is 1 by lambda. Okay, lambda divided by capital T into small t minus x. See student, 1 by lambda is common, so here lambda multiplied and divided, denominator lambda is common. Okay, and the next step here, lambda divided by t, which is equal to velocity of the wave representation student, v is equal to mu lambda, basic equations. Okay student, and replacing that value now, continuation, we will get next equation, that is y which is equal to a sine, okay, this 2 pi by lambda which is equal to k. Okay, this is lambda by t represent velocity v into t minus x. Okay student, and also k value I am replacing here, wait a second. See student, continuation step there, k which is equal to, already I gave you omega by v student, so y which is equal to a sine, k value is omega divided by v into vt minus x. Okay, last step here will be fit student, so that is y which is equal to a sine omega. Okay, denominator v is multiplied, v by v is get cancelled, t minus x divided by v. This is representing again equation number 2 only student. So we did clearly, okay, from equation 1 to different equations. So third equation this, and this is representing equation number 4 student, and this is representing equation 5. And next one, this is representing equation number 6, and this is representing equation number 7 student. Okay, all are different equations useful to solve the numericals in mains level. Okay, now I am going to explain the numericals based on this derivation student. Wait a second. Yes, see student, now here I am going to explain the numerical step by step based on that derivation part only. Okay, see there. So there is a transfer wave is represented by y which is equal to 2 sine omega t minus kx is given in centimeters. Fine. The value of wavelength, what is asking in the question? Wavelength in the centimeters asking, for which the wave velocity become is equal to maximum particle velocity. Wave velocity v which is become, what is that student? Maximum particle velocity. Okay student, in this wave velocity v which is equal to omega divided by k, and maximum velocity which is equal to a omega, both the values are replacing, that is omega divided by k which is equal to a omega, omega is get cancelled. Now I am going to get there 1 by k which is equal to a student. According to the question, amplitude is how much in the question? A which is equal to 2 centimeter is given, is replacing in the above equation. And also next step, k value is 2 pi by lambda. K is equal propagation constant, that is 2 pi by lambda is replacing. That's why we will get there 1 divided by k value is 2 pi by lambda, which is equal to a value 2. Okay student, and rearranging the equation, lambda divided by 2 pi, which is equal to lambda, which is equal to 2 into 2 pi, so that lambda, which is equal to 4 pi, is the answer for the given question. So first option is correct for the given question. Okay, and also next question is there. See student, first one completed, and next question, see, according to this question, here given the values one by one, I will read and replace the values. In the wave equation, y which is equal to 0.5 sine 2 pi by lambda, that is into 400 into t minus x divided by lambda is given student. Okay, so for this, see student, for this question, which is the best one, see, y which is equal to given 0.5 is amplitude, sine 2 pi divided by lambda into 400 t minus x, which is the best formula. See student, according to these equations, different equations, y which is equal to 0.5 sine 2 pi by lambda represent, what is that student? K, that is representing k. Yes, this equation number 7, k into, tell me student, that is 400 into t minus x. So from equation number 7 I am representing, from equation number 7, see student clearly, y is equal to a sine k into vt minus x. So y which is equal to a sine k into vt minus x, comparing the both equations. So simply we will get here velocity v which is equal to 400 meter per second. This is the answer for the given question, clearly given based on the concept we are doing the numericals. Okay student, then next problem, question number 3. See, for third question, for a periodic motion represented by the equation y which is equal to sine omega t plus cos omega t, the amplitude of this motion. See, notice one thing student here, this is representing, this is vertical component and this is horizontal component. See there, y which is equal to 1 sine omega t plus 1 cos omega t, resultant amplitude I am going to find. That is basic equation a1 sine omega t plus a2 cos omega t, resultant amplitude, that is a, writing ar is the resultant, root over a1 square plus a2 square plus 2a1 a2, parallelogram, law of vector formula. And horizontal component and vertical component mutually perpendicular to each other, cos 90. Okay, so that ar which is equal to root over a1 is equal to, according to the question, a1 is equal to 1 and a2 is equal to also 1. The values are replacing 1 square plus 1 square plus 2 a1 a2, cos 90 0, 0 into anything 0 students. So ar which is equal to root over 1 plus 1 plus 0, so ar is equal to root 2 is the answer for the given question. B option is correct. Okay student, and next one, last one, see, last one I am going to explain derivation based on the different equation of progressive waves. So traveling wave is, this is a question, traveling wave is described by the equation, that is y x comma t, y is a function of x and t, that is equal to 0.05 sine 8x minus 40 meters is given according to the question, student. Notice this. And in this equation the velocity of the wave is asking. Okay, so that velocity of the wave, basic equation y is equal to a sine, tell me student, kx minus omega t. Compare the both equations. So comparing the both equations we will get there y which is equal to, by comparison I am writing, so that y no need, so that here amplitude is equal 0.05 and next k is equal to 8 and omega is equal to 4. So what is asking in the question? Wave velocity v is equal to omega by k. So v is asking in the question, student. See there, v is equal to omega value is 4, k value is 8, that is equal to 1 by 2. So v which is equal to 0.5 meter per second is the answer, first option for the given question. Please do like and subscribe our channel Nature of Physics for more videos.